Okay, this video is for related rates. We have mentioned this concept a little earlier. The two variables in terms of another variable, right? Ty dt. You can imagine y is a function in terms of t. Then x is another function in terms of t. So this is called related rates. Then through t, we want to see how x and y are related. Let's see some examples. So let's see this example saying a point moving along a graph. So this is the x squared plus 5y squared equal 36. So the shape, the graph is like an oval shape, something like that. So when we talk about, so we have x squared plus 5y squared equal 36. You can see this is a skewed circle. So it's an ellipse. So the first one we want to see differentiate each term in the equation with respect to t, with the third dummy variable. So this is the invisible variable. Sometimes we call dummy variable. B, we want to calculate a dy dt when xy is given and a dx dt is given. All right, so what do we do? So that's invisible time, right? When we do things, there's invisible time. We can feel the time because we see things change. So we know time is there. So we want to put the time into this equation. So which means we're going to take a dt. We're going to take all this. We're going to take derivatives in terms of t. So d of this in terms of t. So we just have to carry on this dy dt, dx dt, right? So when we take it one by one. When we take derivative with x squared, we get a 2x dx dt. So when we take derivative with this term. When we take with y, we get a 5y dy dt, right? 5, oh, I have to multiply by 2, right? I have to multiply 5 times 2, 10 times 2. Then we add those two. What derivative of 36 with any variable will be 0. So that equals to 0. All right, let's simplify this a little bit. Right? So 2 is here, 2 is here, so we can divide by 2. In that case, we get x dx dt. Think about dx dt as a variable. Plus 5y dy dt equals to 0. Right? So how many variables we have? We have x dx dt, y dy dt. 3 variables, 4 variables. If you're given the value for any 3 of them, we can solve for the 4th. So in this case, we're given this. We're given x equals to 4, dx dt is 5, plus 5 times y as 2. We want to solve for dy dt. So 4 times 5, well, we can divide by 5, right? Everyone has 5 as a factor, so we can divide by 5. And also, everyone has 2 as a factor. So we can simplify this to be 2 plus dy dt. Then dy dt, of course, equals to -2. Okay. So this is called related rates, right? We see 2 variables related with a third invisible variable, and oftentimes time, right? Oftentimes time is time variable. Let's see more examples. So the picture is showing here, right? If you imagine something is on this circle, right? Let's see this circle is spinning, right? So at this point, what is the speed of this not circle, this ellipse spinning? Okay, so we just find out the -2. The speed is decreasing. Okay, let's see this example. So suppose X thousand units of a commodity can be sold weekly when the price is $P per unit. And that X and P satisfies the demand equation. So have this relation, the demand. So in terms of P and X, so have this equation. So the question is asking how fast are weekly sales changing at a time when X equals 4, P equals 6, and the price is falling at a rate of 40 cents. Right? So P represents the price. So what is this given? So this is obvious. This is X, this is P. Well, what is this? This is DP, D dollars, right? DP, DT, right? Because per week, right? So rate of change is dollars per week. Dollars per week. So that's the rate of change. So DP DT equals negative 0.4. Why is negative? Because it's a falling. It's not an increasing. The increasing will be positive. Falling will be negative. So negative. So all we have to do is do implicit differentiation first. So we're going to take a derivative. We're going to d dt of everything. So P derivative is 1. Okay, so 1 times dP dt. And 2x is 2 dx dt. If you want to use prime, that's fine. You could use this is a P prime, this is x prime, all right? But then, so 2x dx dt. But then we see product. So we have to follow product rule. So plus product. But when we take derivative with x, we get 1. So we have dx dt times p plus x times dp dt equals to 0. Because 38, take a derivative in terms of anything would be 0. Because 38 doesn't change with in terms of anything, it's a constant. So I hope this makes sense. So just taking derivative of everybody in terms of t. So how is the price changing in terms of t, in terms of time? How is the quantity changing in terms of time? And here we have x times p, so we need to apply product rule. All right, so you could also use prime notation. That becomes x times p prime. Right? Sometimes it's easier. Well, what is p prime? P prime is given, dp dt is a negative 0.4, then plus 2 times dx dt, because we are trying to find how fast the weekly sales changing, the quantity changing. We're trying to find x prime. So tx prime plus dx dt, well, again, that's x prime times p. Well, p is given 6. Then plus x is given 4 times dp dt, negative 0.4 equals 0. So we got a negative 0.4 plus 2x prime plus 6x prime minus 1.6 equals to 0. Right? These two adds up to negative 2. So move to the other side, we got a 2. Then these two adds up to be ax prime. Because add those two up, get negative 2. So I move to the other side, become positive. Right? 2x prime plus 6x prime, that's ax prime. So we divide by, or x prime just dx dt, which is the weekly sales changing, right, in a week. So the sales changing, the quantity of sales changing per week. So this is 1/4, 1/4. Right, so this is related rates. We use implicit differentiation method, and we use it simultaneously with both variables because we're considering the third variable, time. Right. In the beginning, maybe a little bit confusing. We just have to keep practicing. Right, keep practicing. All right, that's it. That's related rates.